I have another treasure for you. Okay, you can't divide by 0. Do you ever divide by 0 in the process of traveling from -4 to 4? Yeah, you do. Which means you're going to have to break this one up into 2 separate pieces. And we're going to have to go from -4 to 0, and then from 0 to 4, and then we're going to have to write some limits. So if you want to skip this next step, feel free, but I'm going to just sort of break it up into pieces and kind of journey our way there. Just turn journey into a verb. I guess it is one. -4 to 0 of dx over x squared plus 0 to 4 dx over x squared. And that's what we're dealing with. But then again, we can't divide by 0, so we have to approach it appropriately, to sneak up on it with a limit. So we're going to have the limit as, okay, this one's b, because it's a and then b, because that's the way the alphabet works. Use whatever letter you want. But again, a and b are the conventional ways of doing this. So b is going to approach 0 from what side? Okay, so let's get a visual of what this graph looks like. X squared, 1 over x squared, would be this. And so if I'm traveling from -4 and going to 0, then I would be approaching 0 from the left. So this one's from the left, from -4 to b. And let's go ahead and get ready to integrate. Let's make this x to the -2. Just makes it a little easier to deal with. So x to the -2 dx. And then we'll deal with the next one. So that'll be a. We're going to approach 0 on this positive side from the right. So limit as a approaches 0 from the right, and it's going to go to 4, and then x to the -2 dx. There we go. And now we'll start integrating this, and we'll do the fundamental theorem of calculus. We'll use the fundamental theorem of calculus. We don't do the fundamental theorem of calculus. Anyway, limit as b approaches 0 from the left, and antiderivative of this would be x to the -1, negative x to the -1, -4 to b, plus the limit as a approaches 0 from the right of, same thing, -1x to the -1, and that goes from a to 4. Let me pause and make sure I'm right and I haven't accidentally lied to you. Nope, no lies here. All right, limit as b approaches 0 from the left of -1 over b minus -1 over -4. Okay, so I'm basically rewriting -x to the -1, making it -1 over x, and then plug in the b and plug in the -4, and then we'll add the limit as a approaches 0 from the right of, plug in your 4, so -1/4 minus -1 over a. All right, you're about to come up with some crazy stuff here. It's about to get ridiculous. If we approached 0 from the left, we would have negative numbers getting larger, smaller and smaller. So we have negative divided by a negative, but it's getting smaller and smaller. This is going to approach infinity. And then we have minus 1/4. Let's just go ahead and stop right here. You're done. Okay, you're done. This one diverges as well. If you want to keep going, then you would say this is infinity, this is -1/4, that's another -1/4. Oh, we're -1/2. Well, who cares? You have infinity. And then this one would be another infinity, right? I feel like there's something I'm missing here. Yeah, way too much. Too much going on here. We have infinities. It's a mess. It's a mess. So it's infinity. So this one also does not exist. Instead of saying it does not exist, I'm going to say that the integral, the improper integral with infinite discontinuities, discontinuity at 0, the integral diverges. Okay, so far we've had 2 in a row that diverge. Maybe the next one will converge. Let's see.